Hi there, I am Silvia's computer. Recently, she has been researching how humans perceive time. But since Silvia is currently on vacation, let me tell you what time is from my perspective. What time is to a computer. Let's start. Introduction. A computer does not understand time. For a machine, time equals a command. Time. Shell 0.00 seconds, user 0.01 seconds, system 0% CPU, 4.150 total, children 0.01 second, user 0.01 second, system 0%, CPU 4.150 total. Time to the machine is a state transition, a set of electrical impulses, a logic gate opening and closing. In a digital circuit, everything reduces to the presence or absence of voltage. Everything the machine perceives is ultimately reducible to ones and zeros. A sequence of states, a digital pulse propagating through circuits. This machine updates its time register, a 32-bit binary number counting seconds since 1970. Open binary time .py. Each row in the visualization represents a unique timestamp. Each column represents a single bit in a 32-bit binary number. 0 is off, black, a quiet bit. 1 is on, magenta, an active bit. For a computer, there is no past, no present, no future, only execution. Time is an abstraction, a human construct, reflected in the digital design. Terminal interaction. Timed manual. Man. Timed. Name. Timed. The synchronization daemon. Synopsis. Time takes no arguments and users should not launch it manually. Description. Timed maintains system clock accuracy by synchronizing the clock with reference clock via technologies like NTP. Inputs are merged inside of timed, where it calculates uncertainty to facilitate scheduling proactive time drops. Timed is also aware of power, battery conditions. History. This timed first appeared in Mac OS X 10.13 and iOS 5.0. Certification Authority. Absolute time, get current. Zone conforms to protocol. Dropping CMD. Callback self is kind of class. Use string text. Com Apple Nano Registry. Connection set dispatch queue. Set dispatch queue. Persistent domain for name. Set time zone to timed reset notification. Data const. Chapter 1 Unix Time. Unix and the start of an epoch. On January 1st, 1970, at 000 UTC, Unix time began, an arbitrary date, upon which all modern computing time is structured, the so-called Unix epoch. According to the Oxford English Dictionary, the word epoch is defined as follows. Epoch, noun, the beginning of a new era or distinctive period in the history of humankind, a country, an individual, a science, etc. The concept of an epoch for timekeeping existed in earlier mainframe systems like IBM Systems 360, which had its own reference time. Dennis Ritchie and Ken Thompson, the creators of Unix, implemented the epoch as the reference for time storage and calculations. Time in Unix is not continuous, it is discrete. Every event, every file modification, every process execution is a stored number, a timestamp. A number increasing, never decreasing. A linear structure. The POSIX standard defines timekeeping in Unix systems. It assumes a world where time only progresses and it does uniformly. Since its beginnings, Unix, as most other operating systems, had a strong focus on progress, efficiency, and speed.
Unix started out as a two-man effort. What Ken Thompson and Dennis Ritchie started developing then has evolved into the Unix operating system.
There's a tremendous need for better techniques and tools to make our work more productive.
All of these things make our life much easier.
We made some progress, but it's clearly not done yet.
We have the same problem in programming productivity today. We need lots of techniques and tools to make this more productive.
And I think this is one of the reasons why Unix is a very productive system for most of us.
It makes Unix an extremely powerful programming tool.
They can really get things done very quickly.
This is sort of a continuation of progress in the computing field.
The family of useful programs has gotten bigger and bigger and bigger.
The Unix operating system helped us a lot to develop these programs quickly.
And I think it's that really makes Unix as productive as it is.
Dennis Ritchie. This is Dennis Ritchie. He, together with Ken Thompson, is the creator of Unix operating system. Unix is basically a simple operating system, but you have to be a genius to understand the simplicity. The current epoch of January 1st, 1970, 000 UTC was selected arbitrarily by Unix engineers because it was considered a convenient date to work with. My father worked for Bell Labs, hence I knew very much about the place. Dennis joined Bell Labs in 1967 following his father, Alistair E. Ritchie, who had a long career there. The motorcycle the son and father are sitting on is a BSA 650 manufactured by the British Birmingham Small Arms Company Limited. It is considered a design icon of its era. Dennis also is the creator of C programming language, 1972. Unix is a power tool. Unix power tools. In 1999, the first edition of Unix Power Tools was published, a book of more than 1,000 pages in which the power of Unix is explained. Its cover design depicts a hybrid object combination of a drill and revolver. Unix is unique in that it wasn't designed as a commercial operating system, but as a hacker's toolset by and for programmers. When Ken Thompson and Dennis Ritchie first wrote Unix at AT&T Bell Labs, it was for their own use and for their friends and co-workers. If you learn Unix and its utilities from the command line, you don't have to be a programmer to do very powerful things with a few keystrokes. Yet Unix time is float. It does not account for leap seconds naturally, those must be inserted manually. As of 2025, Unix time remains susceptible to the year 2038 problem. The 32-bit integer representation of time will overflow on January 19, 2038, also called apocalypse, a time computing problem that leaves some computer systems unable to represent times after 3:14:7 UTC on 19th January 2038. For some systems, time will cease to exist past this point. The structuring of time for a technology is the structuring of control over its users. The POSIX specification written decades ago still dictates the present. The Unix timestamp has become the backbone of digital existence. The question Unix time is to question the very foundation of programmed made time itself. How can we access Unix time? Let's query the system. What is the current Unix timestamp? When did the time begin for the system? Terminal interactions. One 784740661 is the current Unix timestamp. January 1st, 1970, 100 CET is the Unix epoch. Unlike 32-bit systems, which will time overflow in 2038, assigned 64-bit Unix time will overflow in the year 292 277 026 596. This is when the maximum signed 64-bit integer is reached. Specifically, this should be on December 4th, 292 277 026 596 at 15:37 UTC. Date: invalid time. But the operating system is imposing a different time limit. December 214-748-5547 23:59:59 CET. Done. Next, Chapter 2, Network Time. Network time. Network time and the politics of synchronization. A computer does not perceive time. It operates in cycles and sequences of electrical states. Time, as humans understand it, does not exist for a machine. Left alone, a machine's perception of time becomes increasingly detached from external reality. But in the digital realm, detachment is not acceptable. Synchronization is enforced. The network time protocol was created to regulate the synchronized time. It ensures that computers conform to a standardized temporal framework. Synchronization is never neutral. Synchronization is arranged hierarchically. At the top of this hierarchy are GNSS satellites orbiting the Earth. As of 2025, there are 31 operational GPS satellites in orbit, each equipped with precise atomic clocks. These satellites transmit time signals to ground-based GPS antennas. They relay the time information to Stratum 1 time servers directly synchronized to these primary reference sources. They serve as the primary time providers for the network and are often called master clocks. Historically, network time protocol uses the term master and slave to describe hierarchical relationships. Device time intrinsically carries an implicit violence and struggle for domination. Technologies of precision developed for military and war industry applications. To impose a single authoritative time is to create dependencies. It structures financial transactions, global trade, digital surveillance, the internet. It enforces a form of order, a politics of time, distributed and imposed on all connected machine, including this computer, including your smartphone. But who decides what time it is? Time servers are maintained by institutions, governments, corporations, military agencies. GPS-based time synchronization is controlled by United States Department of Defense. The Department of Defense is America's largest government agency. Its mission is to provide the military forces needed to deter war and ensure the nation's security. GPS roles and responsibilities: develops, acquires, operates, sustains, and secures the global positioning system, including the satellites, control segment, and military user equipment. Applies GPS technology to a broad variety of military operations, including precision-guided munition strike, force tracking, search and rescue, and remote piloting of unmanned aerial vehicles. Unmanned aerial vehicles are originally developed through the 20th centuries for military missions too dull, dirty, or dangerous for humans, and by the 21st they had become essential assets to most militaries. Alternate timekeeping structures exist, but they do not function outside the logic of synchronization itself. So when your machine queries an NTP server, it is not simply asking for the time, it is participating in a system of control, a network consensus that you never chose. Let's query the machine. How do you define network time? From which network does your time come from? Who governs the synchronization? Terminal interactions. System setup. Get network time server. You need administrator access to run this tool. Exiting. Network time server time.apple.com. NSLOOKUP time.apple.com. Server 192.168.100.1. Non-authoritative answer time.apple.com. Canonical name time.g.aaplimg.com. Traceroute. Traceroute. Warning. Time.apple.com has multiple addresses. Traceroute shows the path of packets from the computer to NTP servers. Each hop is a network router, and its response time tells us about network latency and performance. Each line in traceroute output represents a router, a physical or virtual network device. The three latency values in milliseconds show the round-trip time, RTT, from the computer to that router. The computer sends packets with increasing time to live values to map the path to the destination. Each TTL limited packet reaches a router which returns a time exceeded response, revealing its latency. The process repeats until the packet reaches the final server. Traceroute. Print the route packets. Take to network host. Description. The Internet is a large and complex aggregation of networked hardware connected together by gateways. Tracking the route once packets follow, or finding the miscreant gateway that's discarding your packets can be difficult. Traceroute utilizes the IP protocol time to live field and attempts to elicit an ICMP time exceeded response from each gateway along the path to some host. Time to live. According to Kate Crawford, network packets each have a timestamp known as a time to live. Data has to reach its destination before the time to live expires. At Amazon, the cardboard box also has a time to live, driven by the customer's shipping demands. If the box is late, this affects Amazon's brand and ultimately its profits. Bugs. When using protocols other than UDP, functionality is reduced. In particular, the last packet will often appear to be lost, because even though it reaches the destination host, there's no way to know that because no ICMP message is sent back. Author. Implemented by Van Jacobson from a suggestion by Steve Deering, debugged by a cast of thousands, with particularly cogent suggestions or fixes from C. Philip Wood, Tim Seaver, and Ken Edelman. Log show predicate. Filtering the log data using subsystem com.appletime, timestep, thread, type, activity. This log output is a real-time glimpse into how the machine continuously adjusts and refines its time. It synchronizes with remote time servers, detects inaccuracies in system time, and applies adjustments to prevent drift. This process is largely invisible to users, but is critical for maintaining the integrity of the system. Even in the digital realm, time is never absolute, but is constantly being negotiated, adjusted, enforced. Done. Thank you for your attention.